Hello. Today I'm just going to teach on. I'll explain on churn prediction. That is a part of using machine learning in data analysis. And what is churn prediction? Churn prediction is the process of using data analysis in machine learning to identify customers who are likely to leave a service or a market. Is critical in industries like the banking, where returning customers is cheaper than acquiring new ones. And so the machine learning models are trained on customers' behavior and demographics to predict whether a customer will exit or stay, allowing a business to take preventive actions. Now let me explain the model I created here. Remember, my GitHub link is in the description below. And these are important libraries that mostly we do have when we are dealing with ML models, machine learning models. In PADAs, obviously, is for data manipulation. Is a library used to work on tabular data mostly. So like in the CSVs, yes, NumPy is mostly for numerical operations, and Matplotlib for visualization and plotting. And this scalar model selection, we import train test spread. This just helps us for splitting data into training and testing sets. And I have more libraries down there, part by part. And if you've not started using Jupyter notebooks, I uploaded a video on how to run them on VS Code. And it is better because you can run code section by section. So without much ado, let me continue. Here is this is a method for reading CSV files. Yeah, so this is a file containing my data that we'll be using. And as you can see, it has row number, it is a customer, the surname, whatever. This I downloaded the data from Kaggle, so you can also download the data from Kaggle. Yeah, so see the many columns, age, tenor, balance, number of whatever, but one of the most important thing that we needed is this thing to do it exited, because this is what we are looking for. Whether a customer will be sustained, will they stay or will they just exit? So you see, if you want to see the columns, the function. If you want to see the rows, you can do df.head. Maybe you can view the first three. .head, sorry for that. We can view the first three within this cell. Yeah, I think you've confirmed this is a file. Then from here we just want to drop the relevant columns. Yeah, so the row number, the customer ID, they're not important here. And after dropping them, you can confirm the new columns. You find them, they miss here, whatever you dropped. So this one is we'll actually now saving it for safety issues. We just ensure you save the original age. In this line, we're just converting the categorical variables, the geography, gender, cut type, into numbers. Yeah. So in the other project that I had done concerning the what was it? I'm forgetting. I did this project concerning, was it segmentation or was it, I don't remember. Okay, as you continue, I remember, but I remember as you see the TF IDF vectorizer for converting the numerical values to the categorical values to categorical variable, the textual data to numerical variables, the categorical variables to numbers or numerical variables. So as we continue, I've remembered it was on sentiment analysis. So you can check on it. So in this one here, we're just normalizing the features, and this is very important. You realize when you go deep to machine learning, you just realize that behind this method, or behind this feature, is some mathematics to standardize or to scale down our numerical values, because sometimes you find some values are too big, others are too small, and we want to be in a gray area where the values they're not big difference. So we use this standard scaler, and that is it. You can check more on it. So at this point, we want to split our data into training and into testing. In the X, what we want all the column except the exited column. So the exited column, we just use it on Y. So on X, we just drop it, but all other columns, we just maintain them, but only the exited, that would be on the Y, because it is actually the one for the one for training. So at this point, we have this library here. We imported the test train in this way, but to split and train the data, to split the data into training and testing data. And in this line, we can see that the test size is actually 20%. 0.2 is 20%. The 80% you have just you don't have to indicate the train size. You just indicate the test size. It will be the remaining 80%. So this X represent is a variable that represents all other columns except exited, and Y only represent the exited column. So we have them there. So the load-on state, as you know, it ensures that the split is the same every time you learn the code. So it ensures reproducibility. Um, mm, now, mm, basically, the model trains on the 80% training set and is evaluated on the 20% test set, which simulate how it will perform on new unseen data. Yeah, so we're just building building a model. So from there, we want to now to train a logistic regression model. There are many models we can do, but on this one, we just use the logistic regression model. Actually, there are others like the XGBoost and the others. So random forest, then to do with k-means, but here we just use the logistic regression. And these two libraries, for the logistic regression, this one basically it's just a model is for classification. Yeah, because in this model you want to classify the customers, whether you are living or you will just be around, will stay. This the accuracy score is just a metric that checks how many predictions are correct. Yeah. So here we create a variable called logistic regression model, and we store the logistic regression, and then we do the logistic regression dot fit x train and y train, and now this is train the logistic regression model using the training data, the x train and the y train. Yeah, the y train is the corresponding values of 0 or 1, because as you can see here, yeah, these are the values of the y train. Yeah, so the next thing is about the features affecting the channelets, and this is very important. Identifying the influential features, because it will extract coefficients from the logistic model, and each coefficient will tell how much the feature influences the channel. It is sort them in by importance. So as you can see, the complaint it really influences the channel, and see it is the lion's share. So also the issue of whether a member is active or not, here is another key. So the list of all is a point and things to do with age. Yeah, so here I just wanted to plot and see how now these features affect the churn rate. And the first one I started is I just wanted to check on the distribution, and yeah, this was just the thing to do with distribution of the churn. But now I want us just to check now how they really affect the churn. So yeah, I just try to plot a graph of churn rates against the age, and as you can see, the churn rate gets high between maybe age 40, you can see 46 to around 62. These people, they're like exiting the market or that service in a very huge way. So the marketing department should know how to satisfy these people in this particular company. Yeah, and also these people at age 83, 85. Also there's a big issue. But you see, from here to here, the churn rate is very